Welcome back to the stream. It looks like we're live. So, part of what I'm doing here is procrastinating video editing. So, that's kind of a problem. But I think the results are going to be kind of interesting. Yeah, so I've been trying to get this next video edited, which is basically just kind of a step along the long road between no Tuco flyer and a Tuco flyer. So really a video mostly about the current state of the camera as it's attached to the winches and the motion control and a lot of that. And I don't know, I'm having trouble envisioning a way to put that video together that doesn't just sort of bore me to death just thinking about it. So I think I need to find a better kind of narrative or a better way to slice that, because so far right now I'm just like looking at footage and kind of struggling to figure out what in there is relevant. So maybe it's time to step away from that and do something slightly different. So this is going to be a bit more of a continuation of the stream from last night, where I was resurrecting this old project, which was a port of a DOS game. Well, DOS and Apple II, but I was porting the DOS version of it. It's Robot Odyssey. It's kind of a childhood favorite. And quite a while ago, about a decade ago now, I wrote a Python tool which would statically binary translate it into C++ as the basis for a port of the game to the a port of Robot Odyssey to the Nintendo DS. And so I did a video about the just the kind of last known state of that project a little while ago. And then last night we managed to get this thing to actually compile and run on at least an emulator. We could try running it on a real DS also. The controls might be a little nicer, although it'll be a little harder for you to see it on the stream. I'm also not sure if I have the charger for my DS, so that might be a problem. We might have to improvise something. So, the goal of that was not just to kind of get the build for Nintendo DS working again, but to try to maybe spin off a version of this project that could be run on a modern web browser or a mobile phone, or something that won't be kind of forgotten quite as quickly as maybe a single retro platform or a single console. You can still find versions of this game that have been put out there with DOSBox on the internet, but at least from what I've seen, the unmodified version of the game doesn't really run to a playable extent in DOSBox. You can binary patch it to fix that, but I haven't seen anybody actually do that. And so I could just do that, but I'm interested in having my own additions to the game, like some UI tweaks, and possibly integration with, kind of other web-based features, like maybe a web-based schematic editor, better game load and save support, just a lot of other things. And then that could even pave the way for sort of an entire kind of graphics remake, where, kind of more modern sprites are put on the original game engine or something along those lines. Kate's asking if I have a 3DS and a magnet. Is this regarding power? I don't have a 3DS. I have a DS Lite, which is the one that I know I have a working flash card for, and that's the one that I don't have or I can't find my power adapter for. So I probably have a power adapter for it somewhere. The battery has some charge. We could try to play it using the charge that's remaining in the battery, but that's a little bit nerve-wracking. I have some DSIs in various states of disassembly, and maybe one of those works, although I don't know if I have any flash cards that work on those. Piot's asking if it would be useful to publish a small binary patched release. I mean, I published the tool that binary patches it. I don't necessarily want to just publish the patched software itself. I feel like maybe there are other sites that can do that, or other people that'll do that, but I would be interested in publishing something as perhaps a derivative work, so something that something where I think the ideal thing I would like to do is to be able to write something which is unambiguously kind of open sourceable, like something that I can write which is with a license that only contains, or that only covers code that I've written or code that is open source in some other license. And so I could have basically a package which I can release just on GitHub or something, and then the process of building that would create a derivative work based on the combination of that open source code and the original game. So I think my preferred thing would be basically having an open source licensed tool that generates the game binary combined with the resulting binary, which I think would be pretty safe to distribute because there are no active copyright holders for this as far as I can tell. I tried to actually track down who, if I wanted to license this game from someone, who would I pay? And I couldn't find that person, and I couldn't find anyone who could, sign off on it. But it also seems like something where if I put kind of a derivative work based on this, then the combination of not having not having an active copyright holder out there making money on this game right now, the combination of that and having the thing that I put out there be clearly a derivative work, that seems less dubious to me than just putting out the modified binaries. So that's why I've put out the patcher. You can download a Python program that you run against the binary, and it produces a patch. Oh, did you find someone who had already uploaded a patched version to archive.org? That's interesting. But yeah, no, I wrote a patcher. We took a look at that a little bit on the last stream. Oops, this is the right camera. And I think my version had a little bit of bit rot, and someone else updated it to a more recent version of NASM. So yeah, I wrote this thing back in 2009, and it's not a modified version of the game, it's a tool that modifies the game. And from what I've heard, this doesn't actually work on modern NASM, but then I think someone else modified it, and last time we Googled for this, theirs came up first in the results. So yeah, this one. Oh, did you not check that in as a separate diff? Oh, you did. Cool. Oh. Was that just wrong all along? That looks like it was wrong the entire time. That's useful though. That's a good fix, I guess. Okay, it's been a long time since I've looked at this code. I don't quite understand what this fix is doing. I don't know why we're checking to see whether the padding length is even here. I don't know. This might be right, but I'm skeptical at this very moment. But anyway, that's out there. I know my version of that worked at some point with some version of NASM. Anyway, I was getting excited about this other thing, stdweb, which is, well, there's a whole ecosystem of things that make this possible. So there's WebAssembly, which is a relatively recent web standard, which is basically just a more efficient way of distributing compiled applications over the web. So the functionality you get is pretty similar to asm.js, if you're familiar with that, which is a way of, it's sort of a restrictive subset of JavaScript, which allows kind of creation of a little virtual machine inside of your JavaScript virtual machine, which then runs The idea is to make a little sandboxed environment which is easy to target compiled code to. So with ASM.js or with WebAssembly, you get these memory regions that you can treat as your process's memory, like it was some regular compiled code. You can get data in and out, but you have to put the data into that virtual memory space somewhere. And actually, I'm not quite sure how Emscripten's method of doing like procedure calls works, but it has some way of doing kind of simulated procedure calls between the C side and the JavaScript side by placing parameters at some known location in there. I'm curious about this link that Piotr posted. Is that actually a working version? Because it would be nice to verify that we have at least some way people could just play this right now. So this is the DOS version. I don't see anything indicating this has been patched. Yeah, no, so the issue is not that the original game is not preserved. The original game has been preserved for a long time. It just doesn't work on modern computers, and anytime I've seen it running on an emulator, the emulator doesn't really do a good job. So like, yeah, I can't take small steps here. The shift key does not work. And this is an emulation issue. Like, it's specifically related to how old the keyboard code is in this game. And that's what the patch was designed to address. Oh, geez, and that's loud, and it's also really, really too fast, which you can adjust manually with DOSBox, but yeah, so we tried just running this in the JavaScript port of DOSBox on the last stream, and it's exactly this well. This looks like the same thing here, so. Oh, Tuco, you're getting in trouble here. Yeah, so the issue is really related to the original game just not really working too well in an emulator, and there are a bunch of reasons for that. The way this game does sound, it has instructions that just do IO port out to toggle the speaker between a 0 and a 1, and then they have timed loops in handwritten assembly that do those toggles at the right time to make whatever sound effect they want. So to emulate that properly, you have to go through and time, or just count cycles and figure out when those IO operations are supposed to happen. Yeah, I mean, the game was written for an 8086 XT PC, so that machine had a fixed clock frequency. It had CGA graphics, or at least it was written. I think it supported monochrome, maybe. I don't know. I think it's pretty CGA specific. I don't remember seeing any other options other than CGA. The graphics are kind of interesting too, because it pretty much exclusively treats the CGA. I think it was 320 by 200, and so I think it actually treats that as a 160 by 100, or 160 by 200 display, rather, which kind of uses pairs of CGA colors to achieve a dithering effect. All right, so there are various examples, and I don't know. This whole thing is pretty new, but there are starting to be some examples and sort of tutorial content for standard web and for the process of using Rust on the web. So there's some info on webassembly.org. I've already gone through this mscripten toolchain setup. So I've got this mscripten toolchain which knows how to compile C or C++ into JavaScript or WebAssembly. So yeah, it can use asm.js, which is a restrictive subset of JavaScript, which you can fairly quickly compile into kind of a little sandbox executable that knows how, or not executable, but a little in-memory binary that knows how to communicate with the rest of your JavaScript code via this chunk of memory. So then I found this, this Rust demo. This seems to be a little bit older, but as you can see, this stuff is still pretty new. This is all like 9 months old at this point. And so this is a little bit more manual than some of the stuff we'll take a look at later. This goes through installing Node.js, and this actually uses npm to do the build. So it has a package.json which runs a shell script. The shell script, I mean, this is all Linux only. The shell script uses this uses the Perl compatible regexes, which aren't in the macOS version of grep. So this will only work on Linux, really. But it's a nice, like, kind of first example. There are better examples, though, in standard web now. So there are some good simple examples in this directory. And this actually uses another more modern feature that previous example doesn't have, which is cargo web. So cargo is Rust's package manager, and cargo web is a pretty neat add-on for that, which gives it support for building Rust applications for client-side web. So I've got this installed. And yeah, this has a extra config file. You can give it some static files in addition to all the other files. So it can automatically generate HTML. It'll generate a little JavaScript loader, which will either load the rest of your JavaScript asm.js, or it'll be a loader for the WebAssembly. So yeah, I mean, using this seems to be pretty nice. I don't see that example in here anywhere, but it's basically like cargo web build and then cargo web start, I think, to start a server. It builds static files, but just for convenience's sake, it'll also serve those on a local host port by default. So there's some cool examples here in standard web examples. I just built this canvas example, I think. So here it is, just drawing some stuff on a canvas under the mouse. Let's look at the code for this. So we have cargo toml. There's no web.toml, so I guess that's optional if everything is default. Dependencies here, standard web is coming from the repository we're in, but that's cool because this is all pretty much default. The only thing we're depending on is standard web. And then we have an index.html here. Canvas.js, where does that name come from? Is that just the name of the package? So I think that's going to have all of our Rust code and all the library code we depend on in it. And then the rest of this is just us, you know, we can do whatever we want with that. It'll probably make sense for this Robot Odyssey remix to just start out with a canvas that has the same size as the original game frame buffer. But at some point, we'll probably want to switch to WebGL rendering just to do better filtering. And because WebGL for scaling is, at least on some browsers, starting to be a lot faster than Canvas. Peter is asking, would I keep the core of the game but swap out graphics and sound subroutines? Yeah, something like that. I mean, I've already got some binary patches in there, so even that earlier binary patch I wrote in 2009, that had some code which swapped out the actual rendering, just for saving a little bit of speed and saving a little bit of memory so that I could add some other patches in. So that's like on the least extreme end. But then on the Robot Odyssey port, so let me actually open this Robot Odyssey port, because this is what we were working on last time. This is really not playable yet, but it kind of sort of is, and this is the code base I'm planning on starting with. So, Robot Odyssey DS. So I've got it set up to start a new game. I've got like a half-completed game load menu, but I don't actually have any saved game files here. So right now I've just got my thrusters on and I'm wasting energy, so I'm going to turn that off. So the game is running way too fast right now, which also means that regular walking is way too fast walking, and so I want to slow walk everywhere. Which also means I'm holding down this kind of unintuitive button all the time. Anyway, this kind of works. Not very well, but kind of. Oh, sorry, that's loud. And yeah, it does have sound, and the sound is fairly accurate. So I was actually pretty inspired by I think it was one of the Monkey Island remakes, or maybe it was a different Scum VM game. It was one of the games that Sierra written, or Lucasfilms wrote with their Scum VM engine back in the like mid-90s, I think, early 90s. So these games were great. I liked them a lot as a kid. And there was a remake of, I think it was the original Monkey Island recently, where they still run all the original game scripts, but they update the game engine so that it has an additional rendering mode. So you can toggle it between kind of an original mode, which is running basically just a compatible engine, like a vastly evolved code base versus what the original game had, I'm sure, but a compatible engine, the original game scripts, and then you could have the option of either original graphics or updated graphics, and that seems pretty cool. I think I might want to try something like that with this game. So what I wanted to point out here is up here, the top screen is actually just running a normal copy of the game with the game's frame buffer, but the bottom screen has a bunch of stuff that I added, including these two sprites are actually just additional copies of the game that I'm running to visualize some of the game's state, and then I use a different renderer to get the game to draw into a sprite here instead. So I could do tricks like that where I get the game to provide me the state that I want in the right format, or maybe do things like just, well, scrape it out of memory. I mean, I know the in-memory data structures for a lot of the game data, and we could reverse engineer the rest of it. So yeah, this is sort of playable, not extremely playable. So yeah, this is pretty cool. That was the HTML. What does the actual Rust code look like? So it's only this big. It's one screen full. Why do we have a macro here? It's a strange thing to stick in your introductory example. Like, Rust macros as syntactic sugar are a little bit heavyweight. Like, what are we actually doing here? I mean, we're wrapping something in a copy, and then I don't know what... I'm not really into writing Rust macros yet. Like, I'm fairly familiar with most of Rust at this point, but I just have not even touched writing my own macros. So I'd have to look up what all of this means, basically. Is that one or more identifiers and then an expression? And we're cloning the... I don't even know. I mean, it looks like we're passing this... Oh, this is an actual pattern we're matching. Okay, so this parenthesis here, this outer pair of parentheses, not outer, but so this thing here, I think is the entire whatever it is we're matching in the macro. This is me trying to reverse engineer Rust's macro system instead of reading the documentation, but this is also me narrating too much, maybe. So it looks like what they're doing here is, my guess here is that this would be maybe a list of multiple identifiers. And maybe the star here is used to repeat this expression, and then we're also repeating this. It's a little strange, but all right. So maybe we're cloning all of these. Is this like capturing these variables? That seems like what we're doing. It seems like we're giving this event handler its own cloned copy of canvas here. Which kind of makes sense. I would hope there was a nicer way of doing that maybe, but the actual code that's like directly next to the web interface is going to be pretty minimal though. I would actually even like to have a separate Rust package module. What are those called? Library? I think a separate Rust library that is just the translated game, and then a library that's the UI that builds on that, so that I don't have to recompile all the translated code every time I want to tweak the UI. That would be nice. Yeah, so this is interesting. So we've got some wrappers for DOM elements like the canvas. There's some weird things in standard web. There's a macro that lets you just directly embed JavaScript code in Rust, and it just, it actually just transparently turns that into an mscripten remote procedure call. So it's like you're marshalling all the arguments in JSON and then like remote procedure calling into the JavaScript that was wrapping the WebAssembly, calling the JavaScript code you've put in here, and then marshalling the results back. It's not that fast, but I suspect that we're not going to be going back and forth between the DOM and Rust worlds very often. Like that's mostly just going to be rendering frames and, you know, getting some game status out and some input in. So this event handler was that rectangle fill we were just seeing. It's a pretty basic demo, but it demonstrates how to go back and forth. And then on the web side, so let's look at what the output of this looks like. So static, did we build this? Does it not save the build results when we run the server? So I did cargo web start, and actually maybe the results are temporary when I do that. That's strange. Let me try cargo web build -- release. And let's take a look at what a release build looks like. We've got a hello from Belgium in Twitch chat. Hello. And someone else there is a fan of Rust. Yeah, Rust is pretty great. This is only like maybe my second actual Rust project, but I've been really enjoying the language so far. Maybe while this is building, we can look at the standard web page. So yeah, I was mentioning this before. The standard web thing is, it's really just a library that provides Rust wrappers around the parts of the DOM communicating with the web browser. But this also seems to be an interesting entry point. So if you're interested in using the Rust on the client side, this will really show you how to put all the right pieces together. So this is relying on mscripten. It's using WebAssembly if that's available. We're using Cargo Web, which is another really cool project. But this is, so far from what I've seen, this is the nicest entry point for just like how to get started with Rust on client-side web. So I'm also curious, it would be really nice to have a library that knows how to do kind of like emulator style upscaling in the canvas with WebGL. That would be pretty cool. I haven't seen something like that for Rust, but it seems like something that might be useful. Maybe it already exists in the pure JavaScript side and I could just import that. I haven't really decided where to draw the line between Rust and JavaScript in this project, but it seems like with standard web, it makes it natural to just put pretty much the entire thing in Rust if you want to, but if there's a reason to call out to JavaScript code, then it seems like doing so is not actually very hard. So yeah, so we've seen this. This is that macro I was just talking about. It's just automatically serializing and deserializing. Exposing Rust functions to JavaScript, that seems really fun. Yeah, doesn't this look fun? And so, I mean, I guess I haven't really addressed the question of why don't I just have my compiler target JavaScript directly? Why am I going through another language? And that's because my compiler produces extremely unoptimized code. I need some kind of optimizer. So I need some kind of compiler. And I don't think the kind of optimization that I want exists really on the pure JavaScript side. I have seen some projects that seem to be doing like constant folding and dead code elimination in JavaScript, but that's actually fundamentally a harder problem than the problem that I want this to solve, which is doing constant propagation and dead code analysis on code that is much more similar to C or C++. And so Rust just seems like a nice, like more modern language that still fits into that kind of requirement space. And this does seem nicer than just writing C++ or C code to the raw M script and API, since this will do a lot of the interwork between JavaScript and Rust more automatically. Is this thing built? Did this? Does this have a build directory stashed somewhere else? Where are the build products? I feel like I'm forgetting something obvious. I don't still have strace, do I? That is, strace doesn't really exist in macOS anymore. Is there any debug option for Cargo Web? Okay, it was up a level for some reason. So I've got all those build products. All right, let's go to deploy, since I assume these are the nicest it has to offer us. So we have a finished canvas.js. So looks like it's maybe not the WebAssembly version, or does it have a built-in compressed WebAssembly? That's the memory initializer. That looks like ASM.js. I don't know why it compiled to ASM.js just then instead of WebAssembly. This is what ASM.js looks like, by the way. Which is fine. I mean, this should work. It's not the worst. Do I have a... Yeah, I mean, this is fine. I would just like to know how to get this to build WebAssembly, because I wanted to show you WebAssembly. No. Okay, so ASM.js is the default. Native WebAssembly REST backend, which I think this is what I want. Requires target WASM32. I know this is a lot of compiling for a client-side web app, but you know, like I said, I know I need a compiler for this because I need the optimizer pass for the generated code. I mean, I could completely switch strategies and make this entirely an interpreter, and that would likely be fast enough on the web, whereas I wasn't sure if it would be on the DS side. But I like the binary translator. I like how it actually makes the program kind of completely custom, and it's not just like wrapping an existing binary blob, and you can kind of add really interesting hooks anywhere you want them without worrying about the memory layout. Which you could do that with an emulator to some extent, but there's something I like about this strategy. Kate's joking about LLVMIR. Yeah, no, I think WebAssembly had a pretty good answer to that on their FAQ. That's new. Hey, Tuco. Why didn't I not hit this before? Why am I on the stable release channel? Oh, Tuco's over here. How did I get stable set as active? I know I was using nightly before. Stop oscillating. I don't know if Google Chrome has a WebAssembly disassembler yet. Firefox seems to have one. Anyway, while that's compiling, another example that I thought would be really relevant to our interests here, there's actually a Nintendo emulator implemented in Rust on the web using this same tool chain. It's called Pinky. Yeah, Pinky is an NES emulator written in Rust completely from scratch based on only publicly available documentation. You can run it in your web browser. They've got a bunch of homebrew ROMs here. Okay, that's probably pretty loud, sorry. Let me try that again without sound. I do want sound in my emulation. And looking at the way this sound works, it's very similar to how I'm going to end up needing to do mine, basically streaming audio buffers from the Rust code to web audio via JavaScript. Can I make the sound less loud? Actually, I don't know if it was that loud for you. It was loud over here, but I'm realizing I turned down your channel. That's kind of loud. Let me fix that. Oh yeah, it helps if I adjust the right channel. That seems more balanced. Almost like I should save these levels or something. Yeah. A little bit of crackling there as the USB device is hot plugged when I clicked my KVM. This one looks pretty cool. I have no idea how to play it. Oh, I can swap. So I can't, oh, I have a limited number of swaps. Oh, I already messed up. Oh, and falling is certainly very permanent. Okay, so I can swap. I just used up the last of my beans. I think that was a close one. I don't know if my shadow can be hurt by the enemies. Oh. Oh, I thought I could turn around faster than that. You can't really jump. Oh, and I just swapped instead of jumping. Anyway, this seems cool. And yeah, this is all written in Rust and compiled to JavaScript or WebAssembly. If we open this in the inspector, I think this one's built to WebAssembly. So here you can actually see a bunch of the glue between the JavaScript code and the Rust code. So all the embedded JavaScript functions end up in here. It's mostly I/O, some memory allocation. Okay, here we go, and it's fetching js/pinkyweb.wasm. Yeah, and that downloaded is 280K, which is, I downloaded 280K for an NES emulator. That seems totally reasonable. So this is WebAssembly. Isn't it cute? Here's a bunch of the same names that we just saw in the table of linkages back to JavaScript. There's a bunch of code. Look at all that code. There's probably some data in there too. There's more data, mostly strings. So there's a WebAssembly. Isn't it cute? Written in Rust. Our canvas thing compiled. Let's see what that looks like. Cool, so now we have a much smaller .js file, which is just a loader. So that has the stuff that's actually written in JavaScript, and it can load the WebAssembly. It's also going to be, oh, it's not going to be minified. Great, this is actually readable code. That's handy. This is remarkably readable. It's almost like they wanted this to be a module that you can just use from other JavaScript code. All of the memory inside the WebAssembly is represented as like a heap, a single, well, several different overlapping typed arrays. These values, heap 32, heap U8, are just different views into the same big buffer, which represents the memory inside the WebAssembly. ASM.js works basically the same way. Here's the fetch for canvas.wasm. And then this canvas.wasm is kind of large. I'm sure it's just a bunch of library code. But it's like 300K. I wouldn't mind downloading this. I don't know why this is larger than the NES game. Right? I mean, these were both built with Rust. It must just be different. This might be Mscripton's WASM generator. Maybe it produces smaller code currently. Maybe they use fewer libraries. I don't think they use fewer libraries, though, because this was a really basic standard web example, and I think Pinky uses standard web. So we could also try building Pinky. I mean, I've already got it built, but we can try running it here. So I like the way they have this structured. The main Pinky repository has subdirectories for individual libraries. So there's a 6502 emulator, there's a NES emulator, there's a test suite, there's a development UI, there's a libretro plugin, and then this is the web interface. And if we go to the web interface, it has a dependency listed here from the NES subdirectory. Then it has a standard web dependency from Cargo. Profiling options, but yeah. So I built it here into Target. And here it is. What is the .d file? What is dependencies? So yeah, that's just right here, PinkyWeb.js and WASM. That WASM file is small. And so anyway, if we just want to try this out, we can use cargo web, and then start. Oh, that's the debug build. Actually, I haven't done a debug build. I compiled this for release. The debug build should be faster to compile, and it should have a little bit more debug checking enabled. I don't actually know how much slower they run, but this app didn't seem to be extremely CPU limited. Oh, thanks for moderating all the trolls in the Twitch chat. I was like so busy I didn't even notice that. So, anyway, where do we want to start? We have this Robot Odyssey DS repository. Seems like maybe making a copy of this repo and then removing all the DS-specific stuff would be a good start. All right, here's Pinky compiled to WebAssembly, running a server. And here we are, same as the online demo, I think. Or is it gonna not load? This might actually be hitting an error. Oh, are we missing quotes around this string or something? Huh. I wonder if there's some bad JavaScript macro code in here, which is failing to parse at this particular moment, but maybe earlier this was working because I was building it for release. Let's see if the release build behaves differently. Let's make a new repository. See, I hadn't actually made a new repository because I hadn't picked a name for this yet. Still not loading. Same error. Did this just give up on syntax highlighting? It just stops coloring the tokens at some point. See that string at the end does not look even remotely correct. Number out of range, number not an integer type, mismatch. Where is that coming from? Yeah, that looks like an error in the code generation. Many points here. Which code generator are we using? I assume we're generating ASM.js by default, but this looks like it's generating WASM. Why? Oh, web.toml. Oh yeah, there we go. That makes a default to WASM. Do I just have some junk in my target? What to call this? Cat here is good. Basically want a title that's kind of like HD Remix, but not quite HD Remix. I don't really want to just make it about the language it's written in. As much as I like Rust, that's not really the thing that belongs in the title. Robot Odyssey 30th Anniversary Edition. Yeah, that'll doom it right from the start, right? That looks... What? No. This is not even code. Is this... This looks like the condition that goes inside of an assertion. But then it just turns into just identifier salad down here. I feel like there's probably something wrong with my configuration because I was not getting these errors when I built this earlier today. This just has the name of the file right here for no reason. It didn't switch back to stable Rust, did it? No, I'm on nightly Rust. Can I build the examples from standard web? Is this just showing up on Pinky Web? I think I did update at some point since the last time I built Pinky, and maybe that broke it. Let's try the WebGL example. What is this about? WebGL generator? What? What? Okay, so how many code generators are there going to be in this project? I don't need to get into WebGL stuff right away, but I'll probably want to eventually. So these are code generating OpenGL API wrappers, which then somehow tunnel all of the relevant API calls back to JavaScript. Yeah, what is this even going to look like if we build it? Let's make a new repo. So I'm starting it out as just a copy of the Robot Odyssey DS repository. I would use git fork, but you can't fork a repo from and to the same account. So I'm just copying the whole thing with history, and then I'm going to add additional commits to remove the DS parts that I don't want. I don't need to go into details. That'll be in the history. Let's just keep this simple. It's all DS specific. It's kind of tempting just to delete everything and then just cherry pick the parts I want. But that would lose a lot of the Git history, which is kind of interesting to preserve. So I'm deleting anything that's DS specific or anything that doesn't really have any useful content in it, just basically leaving all the stuff that's actually worth translating. And so the C++ stuff here is going to turn in some form into Rust. The Python is probably going to stay Python, but I'll modernize it for Python 3. Hardware sprite scraper. Okay, the sprite stuff is very GP specific, or Game Boy / Nintendo DS. Yeah, so msprite can go. Malloc debugger can go. ARM7 main loop can go, I think. Because the sound engine is pretty separate here. runtime errors. I think we can redo those. Rectangles. Why are we tracking dirty rectangles here? I forget what this is for, but this will definitely get replaced with something different. Oh yeah, Robot Odyssey data. This will definitely... Yeah, these are in-memory data structures for the game. These will definitely be useful. Didn't I have IDB files in there? Yeah, they just don't show up in Sublime Text. How about battery level sprites? These are the extra UI elements that I added for the DS port. I can definitely remove all those grit files, which are metadata for the DS tiling. The PNG files I might keep. I don't know where this font was from. I think it was just some free font that I decided to use for this. Probably not going to keep that. Oh. Yeah, this looks a lot like the in-game font, but is pretty readable on the DS. Not really useful in a web port. Wasn't even in the repo. Alright, what else? Sound engine, sprite drawing. That's pretty DS specific. I'm probably going to trash all of this UI stuff because this is all going to turn into JavaScript. Or maybe Rust, but it'll be very different than a console UI on a handheld game platform with a tile-based and sprite-based UI. So I think everything that starts with UI I can delete from this port. Message boxes, subscreens. Solder button, toolbox button, icons, yeah. This is the whole UI pane. This is the text renderer. Yeah. Oh, this is the scaler. I mean, this is not even the scaler. This is the header file for the scaler, but I think I'm gonna trash the scaler too. Tempting to do started age. Not quite. Oh, here's a generator for the scalar table. This is Python code to generate a lookup table for the scaling engine, which is just so very not what we need. Let's get rid of that. Oh, did I do my own font converter? Why did I write my own font converter? I don't know why I wrote this. It's really simple. It just uses Pygame to render glyphs, and then I think we're just storing the bytes in a table here. It's not even using a separate tool to convert like a sprite sheet or anything. This is a script which checks all the original binaries. This is probably fine pretty much as is. We'll want to update all the Python to Python 3. Yeah. So this is a scalar that goes from CGA 4-color, and it actually, the output of the scalar is actually 16-color, for reasons that this comment explains. Blending, so it's like you have a 4x4 square with a CGA color on each side, and you're blending them. Palette tables. This was one of the more performance bottlenecky parts of the program, as you might imagine. So this is actually written in ARM instead of thumb code, and it runs out of, basically directly out of the cache. It runs out of this stuff called tightly coupled memory. This is data tightly coupled memory, and this is instruction tightly coupled memory. This is the inner loop, just a big lookup table thing. It's a table-driven scalar that just converts blocks of pixels into narrower blocks of pixels using lookup tables. This is a different one that goes to tiles, which is used for the little subscreen graphics with the single game sprites that we're chopping up and turning into Nintendo sprites. So these might be interesting to refer to later, but really don't need these right now. Let's just delete them. Let's delete all the UI. James is wondering if I could use the shader for nicer scaling. Yeah, definitely. That's one of the big reasons to use WebGL. It's faster and you can do nicer scaling. I mean, you can get Canvas on most browsers now to at least give you nearest neighbor, but the optimal scaling I would like for this thing is something which is neither bilinear nor nearest neighbor, but something kind of in between. And there are various options for that. Like there are filters that are based on curves that take an exponent that lets you kind of move them in between very smooth and very steppy. I forget what that one is called. The thing that I've done in the past is to implement it as not a nearest neighbor filter necessarily, but more like an anti-aliased grid of tiny rectangles. And that actually tends to work pretty well. For magnification at least. Because then you still get some slight softness around the boundaries between pixels, which is helpful if you're not scaling up by an integer multiple. You can actually get it to optically look closer to the actual boundaries it's supposed to be hitting rather than the nearest pixel. But with screen resolutions the way they are nowadays, like I can probably just scale with nearest neighbor and it's fine. And I can do that either with Canvas or with WebGL. WebGL just might be faster. This is a sprite allocator. This is very not relevant. Let's delete that. Sprite drawing. Oh, for drawing onto sprites. Yes, that's very tile graphics specific. Sound engine. This is pretty low level. I don't think I'll be able to use any of this. Some of these constants are useful at least. PC clock rate, sample per frame. There's this cleanup urge that's just tempting to delete all the stuff that I think I probably might not use, but I think I'm going to keep the graphics here. I think I might use actually some of this stuff. And I can delete the rest of it later. And I can delete this stuff later and or rename the files. I was going to actually mention the original game's copyright here and be specific that I'm not including it in this repo. Yeah, it's copyright 1984 of the Learning Company, which doesn't exist in the form that it was in when it created this, but I'll just put that here for completeness. Enough of a disclaimer for right now. All right, what do I want to keep? I need this notes repository at all. This is in that other Git repo. It's not doing any harm here though, and it's still kind of relevant. The original is a placeholder. Scripts, I might want to rename that, but it's still kind of useful. I'm going to remove this to old source. I don't think I can do two moves. I'll just check these in separately. All right. So my overall build system here is going to be cargo, but I'll need this to poke at the, I mean, not just cargo plus cargo web, but then I also need to connect that to my binary translator system somehow. So let's grab, let's just make sure that the binary translator stuff works and maybe spend some time updating it to Python 3. Let's grab our original binary. And start a new git ignore. So these scripts don't actually need to unpack the zip file, but just in case you give it an unpacked zip file, I kind of wanted to put all the relevant file extensions in git ignore. In the DS port, all of these little files were part of just one big virtual file system that was then part of the disk, or part of the, well, it could have been part of the NDS built-in file system. The way I was building it, it was really just part of the read-only data in the binary, so part of the text segment, which is not ideal, but I can imagine just throwing these on the web server and having maybe a file system where there's a read-only layer backed by URLs, and then there's a read-write overlay on top of that backed by local storage. So then you could save your own chips, you could save your own modifications, but then these data files could still be loaded in really their original format. But that's just like a bunch of tiny GET requests though, and it might be nice to bundle them up somehow. Maybe still have a virtual file system, but then layer your own files on top of that with client-side storage. Why not? Oh, hey Tuco. Really raising the bar with these commit messages here. All right, let's try to just like merge a really simple cargo standard web example into this basically and try to get the two build systems to cooperate. Actually, is there like a cargo init? Yeah, there is. Actually, yeah, I think maybe I don't want this to be the cargo route. How much do I want the binary translated part to be a separate module or package? I'm imagining this going in two different directions, either this little ecosystem of modules, and now I need to imagine how they're going to be connected and what to name them, or just starting out with this all in one module and maybe splitting them apart if I need to. I do really like putting the translated code in its own module, or its own package. Is there any etiquette for doing this? What's this about? Yeah, I don't know how much I care about actually being able to use this code in different circumstances. Like, it would be kind of interesting to use the same code base to do like a port for Pocket Chip or some other platform, but I don't want to overcomplicate it. Alright, let's try to keep this in one cargo file and see how that goes. let's just copy their example from the minimal standard web example code, just to see if our build system is all right. All right, so we're in this Robot Odyssey rewired directory. We should be able to go cargo web start -- release. Not that I really care about release build versus debug build right now. So these are all dependencies of standard web. What is syn? I know what a lot of those are. Oh, it's a parser for Rust source. What do I use this for? I assume it's for some of the macro stuff. I hope it's a build dependency, not a runtime dependency. I have done a little bit of custom build stuff. In TucoFlyer, there's a simple build.rs that gets the web stuff built. I certainly need to look at this again, though. Oh, address already in use. I can fix that. Great. That was the example. So I want to set this to use WebAssembly by default also. So I just want actually the exact same cargo.toml that we saw in the NES simulator, which was pinky, or not cargo.toml, web.toml. This is default target WASM32. Okay, so we could start adding more web stuff to that, like a canvas and some static HTML. Let's see if we can get the generator stuff working. curious if there's any interoperability stuff existing between this and Python. Not that there's much you could do, but at least like finding a version of Python, like just like OS level stuff like that might be nice. Yeah, so I noticed this thing, Python mixin. It gives you a macro that lets you just embed build time Python code. Okay, so this was completely deprecated. So external mixin was the real version of this. But yeah, this seemed like more of a stunt than a module that you would actually really want to rely on. Right? So I don't think I actually necessarily want this. Oh, include macro. Is there a binary include here too? Because that might be handy. Can I include generated code, which includes binary data? Yeah. The cleanest thing to do here would be to not be just generating Rust code, but to have something which, well, I don't know. I think it depends on what you're after. Like, what would the actually cleanest thing to do be? Just not do this at all. Just run the program in an emulator and not modify it. I mean, some of the point here is about breaking down abstraction boundaries. But, yeah, I mean, the whole thing would be cleaner if I wasn't doing this with the help of Python and NASM, but I don't really want to rewrite that code, and this is what I've got. Yeah, that's kind of handy. So this would let me bake the game's fairly small amount of data into the .wasm file, just in its data segment. Then there's also include stir and probably other versions of that. I'm just getting a feel for what the options are here. In the previous iteration of this, the Python code directly generated a bunch of, well, not a bunch, but for each of the original exe files in the game, it generated an output.cpp file, which had everything that you would need for defining one class, which would then implement that game binary. So I could do something similar in Rust. Like, I could even just have it go through a list of binaries, and the EXEs get some programmatic transformation with patches that are per EXE. Most of the other binaries just get included as bytes. This is closer to how the previous version of this worked, because I had an external tool which would just package up a directory. Let's think about that. Okay, so about these scripts. So check originals. I think we just run this and the output does its thing. Oh, this actually did move some stuff to a build directory. Okay, so we have build, then we have the exe files, and then we have a file system directory. See, some of these files are tiny. I don't want to do an HTTP request for an 8-byte file. I should just be downloading all of these at once. Some of the biggest things in here are these show files, which are cutscenes. I haven't actually reverse engineered the format they're in. They have graphics and sound, and maybe code. Probably not code. This is probably mostly like RLE compressed 4-color graphics. Maybe with, I would expect it to have maybe instructions that are like display a frame, delay, play a sound effect, and then with different formats for each of those. I think play.exe is the actual cutscene player, but that's also the entry point for the game. You can also see these exe files are very small. These are full command lines, so menu.exe and then the command line argument. We ran into this a little bit yesterday, that I think all the game binaries take a numeric command line argument, which is which world ID it starts up in. And so that's different for the tutorials, for the actual game level, for the innovation lab. Ooh, it needs 256K of memory. I think that's how much I'm giving it. Oh, menu here is loading show.show. Maybe this is where the show player. Like I said, I didn't really look at the cutscene player. I'm assuming the cutscene format is extremely simple, because it does not take much code to play it. Tutorial. I haven't looked at this tutorial binary that much either. It's just another version of the game, but it's a little bit smaller than the innovation lab and smaller yet than the actual game. So, this is the library, SBT86. Where are my file permissions? None of these are marked executable. Okay, this one should have a sharp bang. And let's try Python 3. that SHA-1? There's no list of module or list of algorithms because I guess that's up to the build. Whoa, Tuco, you're getting all up in my stuff here. Oh, you're such a good boy. Cool. So that's the checker doing its thing. That doesn't need to be executable. This does. Oh, A2 go. Okay, so BT game. Menu. Play. Oh yeah, renderer. That's a good idea. And tutorial. What? That is a Python 3 something. Okay. Python 3, we're getting that it is not a DOS executable. Probably something about bytes in the header. Okay, so this is actually looking for those hexadecimal patterns that are all over this. So like, where are my good examples? Like this stuff. It's the engine that looks for stuff like this. It actually converts it into a regex and looks for the regular expression. So this would definitely benefit from some care between Python's bytes and strings now. So this is definitely a string. Now we're starting to convert it from a string into bytes. All the division in here really wants to be floor division. From past import division. Oh, what's up here? Where did that come from? This whole thing is a huge hack. What is that supposed to be? This is the very first instruction we're just assembling, is it? forget how this is supposed to work. Let's try running it in Python 2. Why did we not hit any of those prints? The signature match error is quite possibly a separate thing. I'm gonna try a different binary. Let's try game, which is the largest, but also the most important. Actually, this looks kind of like it's not disassembling anything right now. In Python 2, it just seems to not be disassembling anything. In Python 3, it's giving me that one dash and a ret. The only thing I actually changed in here really is the regex engine, so we should probably just debug that a little more. I'm just concerned that I'm not getting these prints. Oh, made to go. Where do we call the disassembler? Alright, disasm to catch, I fetch. It's acting like nobody's calling analyze. I forget how this is supposed to work. Okay, so the whole patching engine runs before any of the disassembly, it looks like. So it looks like in Python 2, I broke something in the patching engine, and so we're failing to patch. Whereas in Python 3, Python 3 finds a patch location and then it fails. So these both just seem to be problems with the patching engine. What did I mess up? Why? I forget why I'm not just escaping everything in hex. I want to know if I can just encode everything like it's a hex byte. I know that conversion is just going back and forth, but I kind of want to make sure that the format is right and throw an exception otherwise. Let's see what this does. Okay, that's definitely making it further in Python 2. Same problem in Python 3. This seems to have an extra quote. That's weird. Why are we having extra quotes there? Oh, because I'm getting a repr for free, but then I'm also explicitly calling repr, so that's fine. And in this case, encoding comes from the input line. Oh, so we're actually hitting those same, I think maybe the exception just changed. I think we were originally assuming, oh, that's right. I was marking these as not having any bytes associated with them because they come from the patch. And that was supposed to hit this code path with encoding set to none. That's just no good. Let's try that. This disassembly actually, I think, does not want to be bytes. I think this wants to be characters, but we've got some bytes in here. args 579. This is one kind of large Python file. I don't know why args is a map. Doesn't look like args is a map. Oh, map, right. Not like key value map. Map isn't the result of a map operation. So I just want to convert that into a list. If you want to have several maps. So that going to a join, that'll be fine. The join is cool with an iterator. This one though, I want to convert this either to a tuple or a list. Let's try a tuple. It should be small and it shouldn't change size or be mutable. Dict values is also no longer a list. Let's make it a list. I can't compare adder 16s with each other. That's not the intended behavior. Oh, I just saw a question about whether there's a way to trace the execution while it runs. Yeah, totally. That's been an extremely useful tool. As for implementing that, I mean, I would just like add print statements to my binary translator here to translate that into the code as I run it, so that as I run it, I can see the progress it makes. If you're talking about existing emulators, I think DOSBox can give you a per instruction trace. QEMU can trace per basic block, which is usually close enough. But yeah, running stuff that you're debugging in an emulator to see what it actually does is usually super useful. So how do you implement comparison in Python 3? Because it seems like this isn't doing what I want, this CMP. Okay, yeah, CMP is no longer supported. Use LT, EQ. Okay, so sorting is now partial equality, that's nice. Let's just implement LT and EQ. That seems better. There's no more iter values, okay. Used to be you'd have to worry about that actually copying the values. It doesn't work like that anymore. More places where we're using strings as data, and these should really be bytes. This is the C++ stuff it's generating. Ord. Oh, right. This was kind of weird anyway. This is a list of single character strings and larger strings. I think just for simplicity's sake, this should combine. I could also use a bytes IO for this. That might be a little faster. Yeah, maybe I will use a bytes IO. This is in Python 2 also. This is a Python 2 docs, yeah. Cool. Not that I care that much about Python 2 compatibility, but it would be nice. At some point, I decided that the right way to represent this was a list of single character strings. And that's... just don't quite understand why I would have done that, and I don't think that's the right answer right now. It looks like this is just trying to be a normal string. Well, bytes. Is there a mutable bytes buffer? Because I think that's what I was trying to do here. Is that also something I can do with bytes.io? It does seem like this is what I want. This is kind of bad, but whatever. This whole thing is so small that maybe, yeah, I don't know. I'm just thinking like overwriting an element into an array is probably much better than that. You know, I can kind of see what past me was getting at. I think the maybe list of single bytes is not actually that bad. This is part of the problem though. Does ORD work on bytes? Yeah, okay. int come from? I assume that integer must have been in my original data as well. That would give me bytes. Is there something new? It's going to be big. Oh, they're mostly numbers. Oh, is this because converting bytes directly to a list actually gives me a list of integers? That's fine. I can make this a list of integers. That is much more normal in Python than a list of single character strings. Or single character bytes in this case. Is that also going to give me a integer? Yeah, that's a big difference. That'll be fine, because here we're converting a bunch of bytes into a list directly again. Oh, int plus bytes. Right. This plus is a problem. So this is supposed to be an indicator that we're starting an RLE packet, so a group of zeros. Then the number of actual zeros as a 32-bit number, and then the byte that triggered us to end a run of zeros. Okay, well, code generation finished. We have btgame.cpp. There's the compressed read-only data. We could switch to a better compressor now that we're on a platform that's a little bit less tiny. And here's the code translated subroutine at a time. Cool. Let's see if all of these modules work. Lab. Yep. Menu. Menu still has some warnings that probably need resolving. Play seems fine. Renderer. And tutorial. Do I want to commit cargo.lock? I think I do. Okay, a few more commits. All right. we could try to get this to generate Rust code. We could try to get it to run from the Rust build system. So 2 steps were necessary here. We called checkoriginals.py, which locates the original binaries according to their hash and puts them in a well-known location here. So we might want that build directory to be a command line argument. Oh, I can't read your username, but because it's tiny and like green on gray, sorry, but they're saying I should use is instead of double equals. That's a good point. I don't think, do I have any more of those? Yeah, so I have this. Yeah, so is like triple equals in JavaScript. It's like an exact object reference comparison. I can't think of any reason why those would be different in this case. Is it possible to have an object which has an equality to bytes? I mean, there's that, but is there something for which this is true, which is not bytes? I guess is my question. So yeah, my question is, I agree that I could use is instead of equals for this, and it does seem slightly more correct, but do you know of a specific reason why I should? Or is it just like a consistency thing? I mean, this wouldn't compare to an instance, right? And in 2 instances, only if their content's the same. But like, that's never gonna be the same, right? Oh, that's why. Because stir equals bytes. And I do actually care about that difference here. Sometimes you might not, but in this case I do. So that explains it. And that's fine, that's an alright place to put that assert. Alright, has anybody already done something that makes it nice to call out to Python from build.rs? Yeah, what does the Rust CPython package do? Oh, do we actually have system dependencies in cargo for this? Yeah, Python 3 sys. I'm not sure if this is going to in any way guarantee we have a command line version of Python, though. This might just be libpython. Yeah, this doesn't have any kind of like external configuration, right? Like I can't ask this module, where do I find an interpreter? It might implicitly give me a libpython. Oh. Oh, actually, I did not expect to see that. That's pretty handy. Run a Python script using the specified interpreter binary. Okay. So this is used at build to get config information. It does seem like we could use this, although it's like kind of overkill. It doesn't really give you much, and this module is mostly focused on something that we don't need. And this doesn't help you locate the interpreter, which is mostly what I would want. So I think maybe I'll take a cue from this and have an option to set the Python interpreter with an environment variable. Like, this is kind of handy. Actually, a way to locate the proper version of Python would make it maybe useful to get this module in my dependencies, and I think this might be what's going on. Is any of this public? Run Python script is not public. Oh, this is all local to the build.rs. Oh, so I can't actually use this. It's just going to serve as an example. What is the license here? Because I might actually want to copy substantial parts of that build.rs. It's the Python license. It is birds o'clock out there. I might have missed the birds. Hi. Alright, so I want a build.rs. So build.rs is effectively a standalone Rust script that gets built during the build of your main crate, your main package. And it can do pretty much whatever it wants on its own. It can also spit lines out onto standard out, which affect how the build works. So it can add additional libraries to the build, for example. There was an example for generating code in the build.rs. Outdoor. Where does outdoor come from? Is that from cargo? Is this an... Okay, I wasn't sure whether this was part of the example or part of the API. So we'll want a lot of this same stuff. We'll want environment variables and process command. Let's also maybe start keeping track of the dependencies. Okay, we actually, let's just copy and paste this as a starting point. And we do want this outdoor pretty much the same as what they've got. And yeah, this is certainly not the best approach for compiling C code. So I want a Python command, Python 3 specifically. I think I'm just going to assume it's called Python 3, which is also not the most portable thing to do. And do I know about input directories? I think this is always relative to itself. Well, I guess we'll find out. Let's try BT game. I'm sure I'm actually going to want a table of here's all the game binaries with all the scripts, the resulting output files, and then maybe even something to like a common interface that lets me run any of those binaries with a similar kind of I/O shell plugged onto it. And this is looking in build. Let's start with check originals maybe. So this has a source dir and a dest dir, which is for the actual file system. It also has, do I use that dest dir at all? Just for make dirs? Really? That seems like an oversight. So let's just use a couple of positional command line arguments for this. So the source directory, we don't really care about the structure, we just scan it for whatever. Finish. Oh, that's just for the message. Okay. Joining the base of our destination directory with the specific path for that file. And let's take out all these build slash lines. easiest way to get an environment variable with a default? I'm really not used to the dark background in these pages. Doesn't look like the color scheme kind of makes sense either. Unwrap or is what I wanted. That's fine. I was debating whether or not I wanted some other directory between outdoor and this, but let's just do this for now. Can I get that same result via cargo web? What did that say? Oh, interesting. Debug builds on WASM32 are currently totally broken, forcing a release build. Interesting. I did actually want a reference. So this returns an entire string, which I don't really want. I just want a reference to that. But then in the error case, this is a reference because it ends up being a pointer to a string that exists in the binary and wasn't allocated. So I could do unwrap or else. I mean, I don't actually want this to be. Wasn't there? Oh, this is the compile time environment variable checker. So I could have a function that happens, that gets called, if this environment variable is not found, which copies this string. I could always be copying it. I could do something else here. I mean, the thing that I want is a reference. Can I take a reference? I mean, taking a reference to the option is different than having an option with a reference inside it. But I'm wondering if there's some way that I can do something like that.
Do you want dinner at some point?
Oh yeah. We should eat at some point. I should wrap this up soon. Yeah, we should get some food. Yeah, I forget to stop working. So the easy way to do this would be unwrap or and then original.clone. This means we always just make an extra string, we just throw it away if we don't need it. In this case it's fine because it's just build script. Not like environment variables or something where I really worry about bytes or CPU cycles, but it just annoys me because I don't actually want this to be a string. A reference would be fine, but what I want is a way to unwrap this reference or grab a reference to this thing. And so another way to write this would be match on this environment variable, and if it's okay, I take a reference to it. Otherwise, regardless of why it's not okay, I return that reference. I could even try to make this smaller if I wanted, putting it all on one line. I don't know if that actually makes it any better. Oh, interesting. So I actually can't do that because doing it this way, I'm dropping this reference to the string. I don't need to drop that, but I am just because of how this is written. Yeah, I don't know what the nicest way to do this in Rust is. I think for now I'm going to do it the obvious but not very efficient way. What is it doing now? Oh, this has annoyed me before. Right now, all the standard out and standard error from build.rs does not show up on the console. It just gets swallowed. It's super annoying. So I'm going to remove this build directory because I don't actually want that. Target, release, what is in target? Do we have any exe files? Hey Took, you just drawing stuff? Is there a way to run just build.rs? in here? Request not to suppress the output of build script. It doesn't check the status code, really? I thought that's what this was. What? This is frustrating. I mean, this is also old. What was the actual resolution of this? How are you supposed to debug this? Like, in what circumstances this actually run? If you would like to see the output, invoke with the very verbose flag. File not found errors. Okay, so we've got output from a couple different things mixed in here because of the multi-threaded build. This is from the check sources. It's finding a file here, giving me the output here. Does this directory exist? Not even. Oh, did we not call that function to make the directory? That would do this. Make dir. We did call it. Where is the build script? This one? That's for standard web. This. Not present. I'm assuming that's the outer. Okay, that's more like the behavior I'm trying to reproduce. So I said outdoor equals /temp out, then I ran this build script, which then ends up calling the Python code with the correct path, and then it just fails to create this file. What does this do without the except for OS errors? Oh, because I'm not... Where was I generating that /fs directory before? Let's do this. I think we can just check whether it's a directory with isdir. Yeah. And make dirs. Okay, now we've got all those files in temp out. So if we actually did this with cargo web start. No errors. There we go. So we've got target, WASM, unknown, release, build, Robot Odyssey, rewired, blah, 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 out. And then here's the actual game data that we extracted. Some exe files, some worlds, some sewer, some 4-bit counter, all that good stuff. That might be a good point to take a dinner break. It still doesn't really do anything, but we're starting to integrate this with a rusty sort of build system. All right, cool. Well, hopefully that was sort of interesting. This project, I don't know exactly where it'll go, but it seems like it could have some good potential to be like a retro game that people would enjoy playing on different platforms. And I've long liked the possibility or the idea of making kind of a modernized version of this. And so the idea of kind of updating it for modern devices while at the same time leaving the door open for a lot of actual gameplay enhancements. I like that. I like the idea of just fixing some of the things that would be kind of nearly unplayable, like giving it better load and save support in general, having So it does actually let you save and load the game at any time, but there was just a lot of disk swapping, and it was hard to see what was in each file, so I've already got some support for example, visualizing the save games with thumbnails. Certainly would want to have maybe a quicker UI for editing circuits rather than the original UI. But yeah, let me know what you think. This has also been a learning experience for WebAssembly and just the current state of the art for writing client-side web code in Rust. So that's also a learning experience that I'm looking forward to continuing. So yeah, the code so far is in scanlime/Robot Odyssey rewired. This will not work at all right now. It is just completely work in progress. But if you want to take a look at the stuff we were doing on the last stream, which does kind of work, then there's Robot Odyssey DS. It's the same deal. The game itself is not included in here, but if you drop a copy of the original game in this original directory and then run the build system, then this will give you a shiny new Nintendo DS cartridge with a kind of partially working port of the game. So yeah, I'll see everyone next time. Big thanks to everyone who supports the channel by sending in stuff, by helping me keep spending time doing this with their Patreon dollars, by being nice to my cat, because being nice to cats is like one of the best things you can do. I think that's extremely worthwhile if you can be nice to cats. So, I'll see you next time.